check the recorder. It is recording from the right channel. And this part I never get. In some classrooms it just works, right out of the bat, and in some other classrooms it doesn't work. It just hooks up to the wrong recording device. Okay, so what I'll do is I'm going to give you guys some spiel first, about why app programming is useful. Most of you already know it is useful, otherwise you wouldn't be here. I just want to present two examples that just kind of happened to me recently, or just occurred to me recently. One had to do with the local okay, it's not mine, I hope, because I think I got mine on a silencer schedule at this point. Yeah, double check. Tasker, no active profile. Yeah, it should be turned off. The ringer should be off. Okay. So anyway, I was contacted by the fearless leader of the local Sacramento biodiesel co-op, and they have been using a pencil and paper way to keep track of which co-op member has used how much fuel and paid how much money. Okay, so at the pump, people would write down, okay, I used 10 gallons of biodiesel, and multiply 10 by the per gallon price, and I'm leaving behind like $50 of cash, okay, and drop it into a little box. But it's all kind of like on an honor system. People just have to be honest and say, yes, I just used 10 gallons. There's no double check, there's no accounting system whatsoever. And when they do deliver the fuel, whoever is operating the site where the fuel is stored has to pony up the thousands of dollars to for the gas truck, basically. Okay, so it's not working. It's not working that well, because some people actually have to contribute more money to keep the balance, going. So I have the opportunity to talk to the owner, not the owner, but the person who started the biodiesel co-op in Sacramento, and he wanted to modernize the whole thing. He wants, to basically use a flow meter to see how much fuel is dispensed, and then use a device of some kind so that people can either prepay, for their accounts with a co-op, or they can pay on the spot and say, okay, I'm going to use, this much fuel, and I'm going to pay for it using this particular account. Okay, and I just thought, hey, instead of using a computer or any type of specialized, devices, just stick an Android device, next to the pump, and make it connect to the flow meter, which can be Bluetooth enabled, and then you have the whole thing. I mean, you just need internet connection to connect to a main website or a centralized database to keep track of money and all the other stuff. Then you're all done. Okay, so that's one thing that I just that occurred to me over the past week or so. And then the other one is kind of interesting. I hope no one is getting a little upset when I talk about this. It's it's a particular air gun. I'm not sure how many people here know about air guns. So I want to show you this particular one because I've been reading up on this one a lot lately. Okay, so I want to show you, and you would say, well, what does an air gun have anything to do with mobile device programming? I mean, why do we even want to link these two topics? I mean, is there actually anything related to these to the topic? Okay, that's not looking up what I want to find. So it's day state MK4. There we go. And we'll just go to. Oh, that's the distributor. Come on. That might work. There we go. Okay, so it's an air gun. All right, it uses compressed air to push pellets out of it. But what is kind of interesting about this is it has a processor inside. It uses a computer inside to control the valving of the compressed air. So shot after shot, it will give the pellet exactly the same amount of energy. Okay. Now, when we talk about pellet guns, we are not talking about power that can seriously hurt people. It can hurt people, but usually not very seriously. What these things are really designed for are for target shooting. Okay, we're talking about shooting at 30 yards, and the grouping is like about a dime. It's very consistent. Okay, so I'm thinking if you look at the picture of the gun itself, so I'll just kind of zoom into this part here. Yeah, my mouse keeps creeping. There we go. See this little LCD display here? Okay, so the user interface to the gun, to the computer on the gun itself, is this little two-line, text-only LCD display. And the interaction part, guess what? Is the trigger itself, and also there's a little switch here. And you can see how it would be kind of cumbersome to go through the menu items, and do all the setups. So what would be an easy way to fix that problem? And lower the cost of the unit too. Okay? Bluetooth enable this thing, okay? So now you can get rid of the LCD display altogether. The trigger does what the trigger should do, and then the switch on the back should do what the safety should do, and then everything is offloaded to a Bluetooth device. So the company can now make an app to run on iOS or Android to do all kinds of configuration. Okay, if you want to remap how the pressure should change the valve firing and stuff like that, you can just reprogram the whole thing. I mean, you can just set all the set points and whatnot. Okay, this is just one example of why mobile programming is actually quite useful, because more and more devices are now Bluetooth enabled. They're computerized. Okay, I can show you another example if this is not something that you guys want to look at. Some people get they don't like to look at guns. I can look at this one. Snap on. Yep.
When a Bluetooth chip costs more than a LCD display?
A Bluetooth chip, yes, eventually it will. I think at this point it is already at that point. The reason is LCD, the manufacturing of the LCD itself, is actually not very easy. There are multiple layers of things you have to sandwich, and then that thing is also backlit, which means you also have LED in the back, to kind of light it up. And the thing takes up a lot of space too, okay, on the gun, or in any type of fixture. It takes up space, and it also requires, that opening, on the receiver, to be opened up, to let it stick through. Without that thing, the manufacturing is a whole lot easier, because Bluetooth can now be done with a single chip, with some peripheral like caps and resistors. So it would reduce the size and the bulk quite a bit. And also, you don't need any special opening on the outside, because now it is all just Bluetooth, and Bluetooth can get through normal metal without any problems. So the next thing I want to do is to look at torque wrench from Snap-on, but this one is digital. And let me see if I can get a close-up picture. This is on eBay. You can look at the price, $434 for a torque wrench. On the other hand, if you ask any car mechanic, they will say it's worth every single penny. They will say, a $450 torque wrench is worth every single penny because you can depend on it. See the LCD display? So once again, we have an LCD display and a little 4-key thing on the torque wrench. Now, why would I use a computer on a torque wrench? Okay, first of all, how many people understand the importance of using a torque wrench? Okay, a few. Okay, very good. So how do you use a normal torque wrench? You tighten it up until it clicks, right? There's usually a mechanism that gives you a click when the specified torque is reached. What happens when you work in an auto shop that is really noisy?
You can hear it.
You may not hear that click, right? And also, do you know how much more force to apply before you get to the target torque? Maybe, maybe not, okay? And also, if you train employees, okay, how do you make sure that your employees do not over-torque something or under-torque something? You cannot know, right? Okay, the customer comes back with a car and say, well, my car has a missing spark plug because somebody forgot to torque it down properly, okay? So can you find out who did it and exactly what torque was used? You cannot, okay? How can this help? Well, if you hook this up to Bluetooth, if this is Bluetooth enabled, then you can have a mobile device to monitor everything. Okay, you can set it up so that by the time it gets to a certain torque range, it will do a beep. It can do something to alert the user this is at the right torque. As a training tool, you can now say, okay, all of you go ahead and work on the spark plug part. Okay, but on your phone, on the computer, you can actually monitor how much torque is being applied for each torque range. So for instruction purposes, you can now say, hey Johnny, over there, okay, I think you're over torquing a little bit. Pay attention to your torque range and make sure that you're not over torquing, because over torquing a spark plug can be a big problem. Okay, when you have to undo it, then you remove parts of a spark plug and have something else that's still stuck in that hole, and that's not a pleasant situation. Okay, so that's why I think the computerization of other things actually make it more and more important to have mobile apps, because now your mobile app, your cell phone, your tablet can actually talk to more devices than before. Is that making any sense? Yep.
Do you get interference if you have lots of Bluetooth devices like in one room?
No, not really, because Bluetooth is designed as a multi-drop kind of protocol, so it is designed to be able to talk to multiple devices. I'm not sure how many on the same quote unquote device you can talk to, but it is designed to talk to multiple devices at the same time.
Oh, I mean, just like interference with other people, like if everyone had like a Bluetooth device and Bluetooth mouse and multiple Bluetooth devices like in one like small area, is there interference?
I don't know. I do not know.
Cover the same spectrum.
They cover the same spectrum, but in Bluetooth you don't specify the frequency.
Yeah.
So that's that's one thing that I'm not 100% sure. But the technology is there, okay, and I can definitely see a lot of applications, why Bluetooth will become more and more useful, because to computerize something used to be expensive, and now it is not expensive anymore. Okay, so just wanted to show you this, because I think I just think that there's a lot of possibilities now. Okay, the other thing which is really exciting is we now have Wi-Fi, in this classroom. So for those of you who are bringing in your own laptop computer and your Android device, you can actually use the companion in order to set up your app and to debug your app. So I will kind of go through that right now. Okay. So right now I'm already connected. I'm going to disconnect from the Wi-Fi router at this point. The Wi-Fi router, by the way, is over here, so I think it should reach all the way down there. I'm not 100% sure. This won't work if you only have your Android device. You need to have Wi-Fi on your computer as well. So if you have a laptop computer, it should work. Okay. So the way it works. Sorry. I'll show you exactly which one to connect to. So if you have a laptop computer that is Wi-Fi enabled, you can kind of follow along. If you don't, you can still, this is all getting recorded, so we can, take a look at this next time. So you just, click on this, and you should see cisp362 is the router that we are connecting to.
Is that connected to the internet full time or not?
It is connected to the internet as well. Yep. So we go ahead and click this one, cisp362. And because I already know the password and specified ones already, it's already connecting. So instead, I will write on the whiteboard the actual password. It is CRIN lowercase 0610. That's the passcode to the Wi-Fi router. So give it a try, see if you can get the connection, because this is a pretty good size class, so I'm not sure, if everybody's on the router, what the performance will look like, but we won't know until we try it, okay? So we'll go ahead and give it a try. Nothing will explode or, do anything bad. Worst case scenario is it's really slow or the router has to reset itself.
I wouldn't imagine it need much performance.
I wouldn't imagine so, but still, I mean, I haven't tried it yet with many connections. So we give it a try. If it's questionable, too slow, then we know, okay, maybe it's not feasible. So are there any questions at this point? If you have a mobile device that you want to use in this class, you also have to set up your mobile device to use the same Wi-Fi router because they need to be on the same subnet. Okay. For those of you who do not want to bring in your laptop computer, but you have a little Wi-Fi dongle, you can bring in the Wi-Fi dongle and just plug it into the computer in front of you. That will work as well. That's actually what I'm doing here. I'm still using the computer here, but I have a little Wi-Fi dongle attached to it. All right. So once you have everything done like this, the next thing you have to do is to set up MIT AI2 companion on your cell phone or your mobile device. So what you want to do is to go to the new website, or just in Google search for it. Look for MIT AI2 companion in Google, and that will bring you to this particular page here, connect device over Wi-Fi, and it gives you both the QR code and also a direct link to the app here. So you will have to install the app on your phone before you can use the companion software. This one is different from the one from version 1. So the one that you already have installed, you can keep it there. There's no need to uninstall that one. It's just that these two programs are different, and this one works for AI2, App Inventor 2.0. The other one only works for the previous version. Are there any questions about the process to get this done? In fact, if you have a mobile device, you can just take a picture of the QR code, and that will bring you to the link as well. Okay. So once you have that link, and you install AI2 companion, click and start AI2 companion on your mobile device, and then when you go to the MIT website, okay, and this is the URL that you have to go to use the new App Inventor. It is newblocks.appinventor.mit.edu. So once you get there, you start up a project under Connect to. Let me disconnect first, and I'll show you how to connect it. So once you click Connect, you seem to have three options: connect to a companion, connect to an emulator, and connect via USB. The other two options do not work yet. Okay, they have not gotten that part to work in Windows nor Linux. If you have a Mac, you can actually get it to work, which is ironic. Okay, it's just super ironic in this case. But anyway, you can still use the companion. When you click companion, this is what's going to happen. Okay, it will give you the usual thing like in the past. So what you do is on your cell phone, you go to your app, your MIT AI2 App Inventor 2 companion. You start the application, and then it will ask you for the 6-digit code. So it looks kind of like this. I'm pretty sure you cannot really read it, but it will ask you for a 6-digit code. You type in the 6-digit code from the screen, or you can just use the QR code as well. So it's XCIJKW. And then you click Connect with Code on your App Inventor, and then it will make the connection between your PC and also your mobile device, and now the app should show up on your mobile device. Yep.
Wireless router, does it have any security?
That's the encryption. CRIN.
Is it WEC2?
It's WPA2. Your mobile device should just ask you for the password. It should know what encryption scheme is being used already. All right. So are there any questions about how to use App Inventor 2 in conjunction with an actual mobile device? Okay, this is the quick and easy way to do it. I personally like this approach a lot, especially if you have an actual mobile device to connect to. So the next question is, what if you don't? Okay, what if you don't have an actual Android device to connect to? So I'm going to back out of this one here and do a disconnect from here. So to pretend that I don't really have an Android device to do my programming. You can still use an emulator, okay? But the trick is you have to use the emulator from another source, okay? This particular version of App Inventor doesn't come with the setup software that has its own emulator. But since I already have the setup software from the previous version of App Inventor, I'm going to make use of that, okay? Now, this is in Linux. Okay, in Windows, obviously the instructions will be slightly different, and I have not played with Windows yet to find out how everything is installed. But in Linux, it is installed here. So I go to /user/Google. Don't try this in Windows; it won't work. And then inside here we have App Inventor, and inside there we have commands for App Inventor, and then inside there is a program called Run Emulator. It's a script to actually start up the emulator. It's the old version of emulator. I think it's version like 2.3 or something, but it works. Okay, it still works. So we'll go ahead and get it started. In Windows, you will have to find out where all the files are installed. I think it's under .app inventor inside your user profile. Okay. So now we have the usual virtual emulator thing up and running. So it takes a little bit of time before this is actually really fast. My home computer doesn't even come close to this kind of speed. Okay. And then the next thing we have to do is to use ADB to install applications and whatnot. And we have to start the server first too. So the next command we have to use is not run emulator, but ADB. Okay, so just change the name of the command to ADB, and then specify start server. Okay, and that should come back just like that. Okay, so now we have a server. We have the emulator up and running, and this part I just have to run it once. You don't run it in DOS or Windows. Okay, it won't work. I just need to find out which port the emulator is using by default. It is doing 5554 and 5555, and I don't know which one. I think 5554 is the one that I need to connect to. So the next thing you want to do is to use ADB again. Okay, I know the command is really long. If you change your folder to there first or add it to your path, it will make it easier. Otherwise, you just have to specify the long path name over and over again. So the next command is to make a connection. So you say connect to localhost : the port number, and I cannot remember which one is the actual port that we have to connect to. 5554. 5554. Okay, well, unable to connect, so we'll try 5555. No, it just. Oh, okay, I see why. Connect to.
Double specify.
Yeah.
Okay. Maybe just remove the port altogether. It would default to whatever.
It will default to one. Okay, push, pull, mu.
Yeah, 555 is used by default.
Okay, right here. But the colon should not have hurt either. Alright, so since that's not working, we'll just connect. Unable to connect, so it's not connecting. I just tried this the last night. Start server has started the server, and connect to localhost. Able to connect to localhost. Right here, the instruction is to connect to host, and then with optionally a colon and a port number. But when I specify the colon and the port number, it doesn't want to do it that way either. I suppose I can list all the devices, but before the connection is done, I don't think the devices will show
Is
up.
it translating localhost?
Sorry?
Is it translating localhost, or does it just see localhost and doesn't translate to an internal IP address?
I think it's not going through TCP/IP because it says it's attached already. So that means I might be able to do an install or do it just a shell first. Okay, it's already connected.
Yeah.
All right, so that's good. So I think by default it already knows what to try to
Oh,
find.
yeah, because what you're trying to do is connect over Wi-Fi, and already has a physical connection.
Yeah, but it's not actually physical, right?
Yeah, but it is emulated.
It finds it. Yep. I think that ADB may be special too. I think it's a special ADB, specially compiled for this. All right. So now that we have an actual connection, I know it's kind of I'll summarize all of this stuff later. You go back to App Inventor, and then what you do is you say package for phone, and then you specify download to this computer. So that will basically start the compile process, and it will give you an APK file in return. So we'll wait for this process to be done. It's not as handy as I want it to be, but at this point, I just want it to work first, and then we can refine it later. It's getting there. It's just taking time. There we go. So after this screen, it will show up another screen to say where do you want to save the APK file. Eventually.
And the alternative is show barcode.
If you show barcode, can it work with the emulator?
Oh,
There we go.
Sorry, that was for Android only.
An actual device. Yep. So when they ask you where to save the APK file, just make sure you remember where you save it. Okay. I'm saving it to my temp folder. So I just click save, and now the file is actually saved. Then I switch back to the command line here, and then I run adb install, and then specify the path, which is tmp/form data.apk. Press the enter key. It's now uploaded to the emulator. Takes a little bit of time to install it inside the emulator. When it's done, the command line will come back. The prompt will come back like that. It says success here. Then I switch back to the emulator, which is over here, and I look at all the apps that are installed. You can find the form data is now here. It is actually installed. I start it up, and I have my app up and running. So I know it's not easy. It's not like you just click a few keys and everything is done. But at least we have one way to get it to work with an emulator, and we have another way to make it work with the companion software. It's not exactly easy, but I think it's worth the trouble because App Inventor 2 has local variables and all of the other things that will help us organize larger programs. Right? So are there any questions about how to get App Inventor 2 to work with your devices? Okay, no questions. I will also do this in Windows, to figure out exactly what steps we have to do, to make it work in Windows. It's the same principle. Some of you probably can figure it out by yourselves, but I will write up the instructions as soon as I figure out how to do it in Windows. All right. So now that part is out of the way, we'll continue our discussion with lists, or more specifically, we are actually working with list of pairs. Okay, how many people still kind of remember what we talked about on the other day? Oh, very good. So this page is not available. Why is it not available? I lost my connection. Okay, it's still there. Uh-oh. Is it refreshing? Nope. I lost the ability to get onto the internet. Okay, I'm gonna disconnect from my Wi-Fi here and then reconnect to my wired connection. See if that's better.
Yeah, mine's not responding either.
I think, oh, mine is good again. So the Wi-Fi portion is, it's not working. I think we probably have overloaded it. Alrighty. Okay, so I will diagnose that problem or bring in my own Wi-Fi router next time to get that part to work. So getting back to our class content. Now that I can at least get back to the class content, it's just the Wi-Fi portion that's not working because I'm still going through the same router, except I'm going through the wired interface in this case. So we'll find a different router, that can handle the load of this class. But what we'll do now is we're going back to lists and continue our discussion. And we'll take a look at the drag. I think, have we taken a look at the drag program? I think I only talked about what a list is and what a list of pairs is. So now is a good time to actually go through this particular sample program called drag. Okay, it can basically remember the coordinates of the drag points so that you can do processing later on. If you want to do gesture recognition, you can do that. If you want to do other things, you can also do that also. One other application of remembering the coordinates of a drag is when you want to draw something on a canvas and you want the ability to undo it, this would let you undo it because it is actually remembering the vertices of all the points of what you have drawn at that point, so you can actually undo things one at a time and redraw everything if you want to. Is that making any sense? Okay, so we'll just go ahead and work with this little program here. It's all done step by step already, so there's nothing you really have to invent or to create. You just have to kind of follow the instructions here. So I'll go ahead and just use App Inventor, to do this particular app. Go back to my projects. Drag Recorder is the name of the application. I'm not going to click on Drag Recorder because it's all done already. I'm going to do it step by step so that you guys know, can kind of get familiarized with App Inventor 2. The interface is about the same, but certain things are done a little bit differently, so I want to show you how to get it done. So we'll go ahead and create a new project. That part is pretty much the same way. So it's a Drag Recorder. I'll just call this Drag Recorder 2. And then we start with the project. Okay, this part is almost exactly the same as before. We'll drag and drop a canvas, and then we'll go ahead and change the width and also the height of the canvas to 300 by 300. Okay, so 300 pixels wide and 300 pixels tall. So now we have a good sized canvas so that we can recognize or register the drag events. Next, we'll go ahead and create a label. Okay, so we'll drag and drop a label here. The purpose of the label is just that we have one way to display the coordinates of all the points. Okay, it doesn't really serve any purpose other than that. So the initial text of the label, we'll just kind of rename it to points of drag. Okay. And just to make this app a little bit more interactive, because the way it was done before had no visual feedback whatsoever. So I'm going to change it just a little bit so it has a little bit of visual feedback so you know what is the point, where's the point that you're dragging. Okay. So we'll go to animation here and drag and drop a little ball, which is a sprite. Okay, that's all we're going to do. Into the canvas. Remember, a sprite can only be dragged into a canvas. It cannot go into elsewhere, in an app, in the screen. Are we doing okay so far with this app here? Those are all the components that we need for this particular project. Any questions? No questions? Okay, so we'll keep it simple at this point and just have these three components of this particular app. One thing I really like about App Inventor 2.0 over the previous version is when you want to go to the blocks editor, you don't have to go through the whole process of web start, Java and all that stuff. You just click blocks up there and it will open up the blocks editor. It is a part of your browser. It doesn't require anything special to install, and it's right there. Okay. So are there any questions about using the blocks editor in App Inventor 2.0? And they even give the initial screen a name. It's called a designer. So if you want to switch back to the previous screen where you can see all the components, you just click designer. If you want to go to the coding portion of your app, you go to blocks. All right, so now that we're back to blocks, we can now start to actually write our app. The other part that is changed is how they organize the blocks. It used to have 3 tabs. Okay, the 3 tabs were built-in, My Blocks, and Advanced. All the built-in ones, are like the control structures and whatnot will be in the built-in. All of your components will appear in My Blocks, and then you also have the Advanced block. That is changed to a much cleaner. I think it's a much cleaner interface like this. The built-in ones are here. Okay, you can also kind of collapse the blocks if you want to. And then everything that we define, all the components that we drag into the app, they all appear down here. Okay, and they're also hierarchical because now you can see that the screen is containing the canvas and also the label, and then the canvas is containing the ball. So with one single screen, we not only can access the components, but we can also quickly tell which one is inside which other one. Okay, how they are contained within each other. And I really like that aspect as well. I mean, this is a really cool feature. Okay, so we'll go ahead and start to do something about our app here. We can start with canvas. Okay, we can also start with ball. Okay, so because they are really about the same from this particular perspective. So the first thing we want to do is to handle the touchdown event of the ball, because when you first touch the screen, okay, that's a touchdown event. That's when I want to clean the list, start from scratch, and put in the very first point of the entire drag event. Is that making any sense? Okay, so that's what we want to do here. But in order to keep track of the entire list, I also need help from a global variable. A global variable is needed in this case because it has to exist outside of each event handler, so that's why it has to be a global variable. To make a global variable, you click Variables, and then you click Initialize Global Name to. So this is all you have to do, and I'll just name the global variable points in this case. And you don't really have to define it or initialize it to any specific value, because the touchdown event will do that. Okay, it will just go ahead and initialize it to a list with one single item. So are we still doing okay so far with the new version of App Inventor? Because I think most of these things already exist in the previous one. It's just that how we find all these different blocks is now a little bit different. Okay, all right. So let's go ahead and continue with the touchdown event of ball 1 here. So this part is deviating a little bit from the example in the notes, but for the most part it's the same. Okay, so the first thing we want to do is to empty out the entire list. So we go to lists here. We go to variables, and we want to use the block called set something to. Now this is also completely different from before, because before, if you have a global variable and you look under My Blocks, it will list set blah 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 to, and for each global variable it has its own block that you can select. Now it is only one generic block that you can select or drag into your program. But from here, you can use the drop-down list here to say, oh, which one do I want to set? Do I want to set the arguments x and y, or do I want to set my global variable points? Well, it is global variable points. So what this is doing is really helping to clean up the left-hand side, because if you have 20 gazillion global variables, then you won't have to select from 20 gazillion things. You just have one thing, and then from the drop-down box, you select one of the 20 gazillion things, which I think is actually a better way to do it. So what we want to do is to set our global variable to a single list. Okay, so we go under list this time, and we say we want to create a list, make a list. Okay, now when you make a list, this particular block has 2 sockets. Okay, let me point out where the sockets are. It has one socket here or connector here and another socket here. So that means we are, by default, is trying to create a list of 2 items, okay, or is trying to do that. You can make it, you can change that, okay. If you click the plus sign here, it will give you a little call out box, and in the call out box, it is describing the details of this particular construct. So right now it's saying I'm trying to create a list with 2 items. If you're trying to create an empty list, the easiest way to do it is to drag these 2 items back to here, then you're creating an empty list. If you want to create a list of a single item, then you just say a single item. Just drag item into the list, so now you're creating a list of exactly one item. That aspect is completely different from the one before, but I think this makes more sense. Okay, it gives you a lot more control. But when you don't need the call out box anymore, like this is exactly the way I want it, you just click the symbol here and the block goes away. Okay. Are there any questions at this point about the newer interface? No questions? All right. So we'll go ahead and make our list. How do you represent a point in 2 dimensions? How many different items do we need to represent a point? 2 things, right? We need, most of the time we use horizontal versus vertical, so we have the XY coordinate. Some other times we use the polar coordinate system, but that's not what we're going to do here. So we'll just go ahead and make a list of another item. The other item is also a list, and that list has exactly 2 items. Okay, so this is already creating a list. The top level list has only 1 item, but that one single item turns out to be a sublist, and that has 2 items, which would be the X and Y. In other words, we want to get the XY of the touchdown event and store that into the list. To do that, once again, you go to variables, and this time we use get. In other words, we are only referring to the value of something. We're not changing the value of something. So get will basically get you the value of something without changing it. And we'll need 2 of these, so I just copy and paste it. Control-C to copy, Control-V to paste, just like before. It says it's invalid because I haven't picked out what to get yet. So I can say get Y, which is our argument, and also get X here, which is also our argument. Okay. So this part is also different from the previous version, and I really like this a lot better. Okay, because it just at any point get. If you look at the drop-down list of get, it shows you what you can actually access at that point, which I think is great. I mean, it's impossible to specify the wrong thing, using this method. Are there any questions at this point about touchdown? Any questions? Yep, go ahead.
Did you ask Inventor is relatively stable?
Sorry, say again?
Ask Inventor 2, is it relatively stable for the most part?
As far as I know, it is. I have used it quite a bit more than the previous version now, and I think there are some issues with some of the blocks, like replacing a certain item in the list doesn't work. So I have to get around it by deleting something and then adding something back. But other than that, I could not find any problems with it yet. Right, so that is that. If you want to, you can also update the label to reflect this, but I'm not going to do anything just like that yet. So we'll go ahead and just say, okay, touchdown is done at this point. After touchdown, we want to handle the drag event. Okay, so we'll go ahead and handle the, well, maybe not. Okay, maybe not yet. We'll deal with touch up first. Okay. Touch up is the last event in a drag, because touchdown is the first event. You basically say, okay, now we start the entire sequence. But when you lift your finger off of the touch screen, that's the last event. So that would be the last point of the entire drag. Hello, Walter.
I just wanted to bring this over to you real quick.
Oh, okay. Thanks. That's the computer that you were talking about? Okay, thank you. Here. Okay, so touch up is the last one. So what do we want to do, when this is the last one that we are dealing with? Well, we want to attach that point as the very last item in the list. Okay, so that's the first thing we want to do. So we go to lists here, and the second item is what we need. It says, add items to list. Okay. What it is not saying is we are adding these items to the end of the list. We're appending the item as the last item of the list, which is really handy because that's exactly what we want to do. Which list are we attaching this item to?
Points.
Points, exactly. So now you go to variables, you say get global variable points. That will specify the list that we are extending. And then the item is going to be exactly like this. So I'm lazy, and I will just do a copy and paste it here. Specify X and Y. But this time, this X refers to argument X of the touch up event, not the touchdown event anymore. And the same thing with Y, it is referring to the Y value of a touch up event. Are we doing okay so far at this point? Okay. Next question. How do I debug this? How do I know the list is actually constructed properly? Just the way it is, it should give me at least 2 items, right? The list should have 2 items in any type of drag, because it will register the touchdown point. It should register the touch up point as well. So the list should have at least exactly 2 items, and each item is an XY coordinate kind of thing. Okay, yep.
Is there, where's the name of the list? Is this the
Points.
Oh.
That's my global variable, which is containing the list. Okay. All right. So now I give you the third item here. I can print it out as a label with one single block, okay, which is really, really cool. So we go to lists here, and list, you can see you can do a lot of stuff with list. But what I want to do is, one of the last part here, it is list to CSV table. And we want to use it to specify the label of label 1, or the text of label 1. So we basically drag and drop the set label 1 to blah 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 block here, and then from the drop down box you specify we are changing the text property and not the background color property. So this part is also changed from the previous version of App Inventor. The previous version of App Inventor will give you a whole bunch of set label 1 to blah, set label 1 to property dot property to blah. So it gives you a huge long list when you really need a drop-down box to specify which property you're actually changing. So I really like this interface because it's a lot cleaner. So now we are changing label 1's text property to a table that we are creating from a list. Which list are we talking about? Global points. Okay, points as a global variable. So we copy and paste this one here because it's actually faster than selecting it from the other side, and we're done. Okay, we are done with the most critical point of this particular program. Then you will say, but what about drag? Isn't drag the core of this program? Yes, it is, but it's also the easiest portion of it. Okay, so this is actually the most difficult or the most involved portion of it. So now we are ready to run the app. So I'll go through the same exercise using the command line interface to install the app in the emulator so that we can all see what happens when we run it. So the first thing we want to do is to download the app to this computer. Okay, so we'll have to go through this process to compile, get the APK file, and then we will install the APK file to the emulator. Yep, go ahead.
Are we able to upload our current projects to MIT new app Inventor and then have it work properly, or do I just start from scratch?
There's no way to port programs that you wrote with the previous version to the new version. Yep.
I was able to rename the file and get the interface part of it, but all the code just aired out and just cleared it out.
Yeah, I think they changed the representation inside, and that's why it doesn't work. Yep.
So we're going to be using this one, or the old one still?
I would say the new projects, we want to use the new one, but your driving thing, we'll keep using the old one because we want to keep. I don't want you guys to have to start from scratch. Okay, but the new projects, we will try to use the new one. All right, so it's almost there. All right, it's asking me where to save it. I'm saving it once again to my temp folder. So just click save, drop back to my command line interface here, and just install this time a different app. What is it again? It's called drag recorder2.apk. Press the enter key, and it's uploading, installing, and in a few more seconds, it should be done, and then we can test it in the emulator. Okay, so now we can test it in the emulator, which is over here. I will have to exit out of the other one, and then now you can see drag recorder is now an app, so I can go ahead and run it. All right, so this is my app up and running. Yep.
Is the AI2 companion just basically a friendly interface Isn't it just using ADB as a workaround to connect?
I think eventually it will do. Yeah, it is basically a front end for ADB. What it does is it allows both computers to register their local IP address, so they can find each other even though they're on a subnet, on a local subnet. But I think they do communicate just by ADB in the back end. All right, so we are ready to run the app here. Okay, to run the app, my pointer is really my finger. When I press the left button, it's actually emulating a touch event here. So if I do this, it should touch it, and then when I let go of it, it finishes, and now it is reporting 2 points. Okay, the first point is the touch down point. The second point is the touch up point. Okay. Well, how come the little ball is not moving? I mean, isn't it supposed to be moving? Remember, it doesn't move by itself, right? You have to actually change its coordinate to move the sprite around. Okay. So are there any questions about the program at this point? We just intercepted the touch down event and also the touch up event. But the main point is, hey, if I want to display the content of a list as a label, as text, this is all I have to do. Okay? And once you can do this, you can save it to a file. You can save it to a CSV file. Then you can upload it back to a computer, like a desktop computer, use a spreadsheet to open it, process the data any way you want. So are we doing okay so far with this particular program? Okay, so we are now ready to go back in and finish up the program. We'll really just finish it up and make it a little bit better. So the next thing I want to do is to go back to ball 1, and this time we want the dragged event here. Okay. And there's really not a whole lot we have to do with the dragged event, because the only thing we really have to do is to keep adding things to global points. Okay, keep adding things to the list that I'm maintaining here. And because I'm lazy, I just do a copy and paste it, and then we specify the things that are lost in the process. So we basically want to register the current X and the current Y when we are dragging, because previous X, previous Y are referring to points from the previous event. Start X, start Y should match touch down, because that's the origin of the entire drag motion. So that should do it, right? The other thing we want to do is to update the sprite itself, so it would kind of follow the touch point. So that's what I'll do next, is to go to ball 1, and then we update its location. Okay. Point toward move to, so we'll just use a move to block here, and then the X and the Y would be just current X and current Y here. So you just copy and paste it here, copy and paste it here. Change current X to current Y. I forgot to paste it from the other one. Yep.
I'm sorry, I wasn't thinking to do this or not. I just figured this out, but if you right click, you can click on duplicate instead of having to do Control C, Control Y.
Yeah, that works too.
Yeah. Oh, thank God. That makes it nice. I can just sit here on the mouse.
Oh, you don't have to touch the keyboard.
No.
I can see why people do not want to touch the keyboard, because according to Mythbusters, the keyboard is one of the dirtiest, it contains the most germs, next to a sponge in the kitchen sink. That was the most dirty thing they found. It's worse than toilet seats. Yep.
I was going to say the lemon wedge that there's waters at restaurants. People get sick off that really easily too, because they touch the edge of it and then they drop it in the water. So many people are touching the lemons in their gut.
So now we need to carry our own little UV sanitizer thing and zap everything before we touch anything. No, it's okay. A little bit of germs will just strengthen our immune system. All right, so I think our app is all done. So I'm gonna do it again. Do the download this to this computer. Make sure it goes through the whole process. So yes, it is not as convenient as the other one, because the other one just keeps updating the app running in the emulator all the time, the whole time. This one is a little bit, more cumbersome. Yep.
Working on that right now.
Oh, okay. But at least it is one way to make it work. All right, it's almost there. Okay, so now it wants to save the file again because there's already a file of that name. It's trying to come up with a different name. I'm going to change the name back to here and just overwrite it or replace it. And then I switch back to my command line here, and it keeps track of the previous command, and I just want to rerun the previous command, so I just press the enter key, and it uploads the app and install the app remotely. Already exists and doesn't want to do it that way. I'm pretty sure there's a switch to make it install even if it's already there. I just have to read the instructions of how to do it. Install -R. Yep, there we go. So you just say install, but put a -R next to it, so that way it will just overwrite and reinstall the application. It keeps the data though. It doesn't wipe the data. It keeps the data, but it reinstalls the app. Success. We'll give it a try. Okay. So now we can switch back to App Inventor, restart drag recorder. And this time we'll drag the ball around. You can see the ball now follows the touch point. Let go, and now we can see all the points. Okay. This is a single label. All the points, the printing of all the points is just really one single label, but it's pretty long. In fact, it is so long that you can use the scroll to scroll down to the last item. Are we doing okay so far with this little app here? Is that okay? All right. So now that we have an interesting way to create a list like this, let's see what we can do with lists. Okay. Last time I already talked about what you can do with a list. You can pass a list to the next screen. You can save a list. You can restore a list. You can do all kinds of cool stuff with lists. Okay. So what we'll do now is extend our drag recorder program to beyond what we talked about in the notes. Okay, that is already written, and you should have read it or portions of it already. So we'll go ahead and extend this program a little bit. So the first thing I want to do is to pass it on to another screen and have the other screen having a canvas to draw the entire line based on whatever is recorded with drag. Okay? Are we doing okay so far? Does everybody understand what I'm trying to do? Okay. So let's go ahead and do it, because I also want to show you how easy it is to create a second screen with the new version of App Inventor. Okay? So we'll go ahead and say, guess what? Add a screen. Okay. So the new screen, I'll give it a name. We'll call it screen paint drag. Okay, or draw drag. Okay. Because that's what it's going to do. It's going to draw a line corresponding to the drag from the previous screen. Okay. So obviously, it also needs its own canvas because that's the only place we can draw something, and we'll also make it 300 by 300 because otherwise we may have points that cannot be drawn in this particular screen if we make this canvas smaller than the other one, just like that. And I think that's all I need. Okay, this is really all that I need. And we can switch back to screen 1. So if you want to switch to a certain screen, you just click the drop down box for screens and click the name that you want to switch back to. Okay. I need a new button because I need a button to trigger the operation to switch to the second screen. Okay, so I just need a button here. So we go to basic, drag and drop a button, and I will change the name of the button so it reflects what it's supposed to do. So this one would just say draw in another screen. Okay, because that's exactly what it's supposed to do. Okay, it will trigger the operation to draw the drag in another screen. And if you want to rename the button name itself, so when you look at the blocks editor, you know which one we are talking about. So when I name these things, I could have used just button, but it's kind of long, so I will abbreviate it to BTN for button. Draw in another another screen. Okay, I'll just call it draw because that's clear enough to me what it is. Okay, so now we go to the other screen, switch to screen, draw, drag, and switch to blocks so that we can specify some code with the other screen. Once again, screens do not share anything. Okay, the first screen and the second screen, they don't share a single thing. Okay, in the second screen, you can still go back to the first screen. In other words, in the blocks editor, you can still switch, just over there. And I'm gonna switch here because I have to specify what the button is supposed to do. So now I go to button draw, and I say when button draw is clicked, go ahead and do the following. Okay, I want to switch the screen. Switching screen is pretty much the same as before. It is still under control, the control tab here, and it is still called open another screen, but there are two options to open another screen. The first one is just open another screen name, and then you have to supply the name of the other screen that you're starting. The second one is the one that I want to use because I have to specify two items. The first item is the name of the screen that I'm switching to. The second item is a start value. I can actually pass a value along to the second screen. Okay, so I'm going to use the second block here and put it into the click event. The first part is pretty easy. I just have to remember the name of the second screen. It is called screen, draw, drag with uppercase of each particular word. Okay, you have to remember the case of the word because it is actually case sensitive. So now we put a text block here, and then just spell out screen, draw, drag with capitalization at the right places. Okay. And the next thing we have to specify is our start value. Now, this is where a list comes in really handy because it seems like we can only specify a single number as a value, but you know what? You can also pass an entire list as a value. Okay, so this is really cool because now we can just say, go to variables, drag the get block here, and specify global points. Okay, it doesn't complain. We have one warning from the global variable declaration because I did not initialize it to anything. But other than that, everything seems to be fine. Okay, so on the other side, how do we get the entire block? Get the entire list. Well, let's go ahead and switch to screen, draw, drag here. And I don't really want to do anything on this screen except to say, okay, I'm just going to draw the line representing the drag events, and I'm done with this screen. Okay, I'm not going to do anything else. So we go to screen, draw, drag, and then we say when it is initialized, do the following. Okay, in other words, when it started, do the following. This is also where local variables can come in handy because I don't really need a place to store the entire list. Okay, because everything that I need to do with that list, I'm gonna do it within this event handler. I don't really need a global variable for that. What I really need is a local variable. Okay, something that is only accessible and exists within a particular block of code. So what I'll do is I'm going to click on variable here, and you can see that we have the usual stuff. We have the initialize global name to blah blah blah, but we have two additional blocks that are completely missing from the previous version of App Inventor. Okay, the last two. The first one is initialize local name to blah 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 and do blah blah blah. The second one will return a particular value. I'm not going to return any particular value, so I'm going to pick the first one. So I will just pick it and put it there. The little plus symbol, once again, will give you a call out box, so you can actually define any number of local variables within this block here. Okay, you just have to drag name into local names, then you can define additional local variables. Or if you want to define only one, you can drag the other two back there, then you're only using one local variable. So do we have any questions about this? No questions? This is all good? I think it is extremely handy. Okay, it's very handy because this time, what I can do here is to name this local variable name, once again, points. Okay, and this points has absolutely nothing to do with the other global variable points, other than the fact that we pass the value from one screen to the other screen. But other than that, the variables are completely disconnected. They are not related to each other at all. What do I want to initialize it to? Well, once again, we go to control, because what we want to do is to say, oh, this local variable should be the list that we are getting from the other screen. And if you scroll all the way down, you can see get start value. And that's what we're going to do. The start value for an entire screen is the start value passed by the other screen, by the initial screen, the first screen in this case. So this time, using this method, I'm passing the entire list from screen 1 to screen draw drag, and put the entire list into my local variable called points. And now I can just go ahead and go through each and every point and make connections amongst them. Are we doing okay so far with this code here? Okay, very good. So what do we do next? Next, we want to go through every single item in the list. Well, that sounds like a drag, right? No pun intended. Yep. There's a very easy way to do it. Under control, we have, well, there are several ways to do it, but this is really one of the easiest way. But unfortunately, in this case, I cannot use it because we have to attach to the previous point. Okay. So what we really have to do in this case is to use this method here. For range, I start from a certain point, and at a certain point, step a certain point. This construct has a long history. It traces its way all the way back to Fortran, which is a very ancient programming language. It also exists in BASIC. Okay, I'm not talking about Visual Basic. I'm talking about really early basics, like even earlier, Apple Soft Basic. On Apple II computers, okay, there's a basic interpreter called AppleSoft, and guess which company made AppleSoft Basic? That runs on Apple computers. No? Microsoft, exactly. That's one of their earliest products. All right, so now we'll go ahead and specify what to do with this, okay? So what this block is doing, it is a loop, okay? So what it does is it will do certain things over and over again. So the question is, how do we specify how many times something gets done in this case? It has a start value, it has an end value, and this is a step, which means for each iteration, I is going to be incremented by this amount. You can specify a negative number if you want to decrement. Starting with 1 is good because we want to start with the first point, or maybe that's not what we want to start with. Maybe we want to start with the second point. Okay. It has to be off by 1, either with the starting point or the end point. I'm going to change the end point here, so it's going to be off by 1. Okay, so we start with the first point. How many points do you need to draw a line? Right? You need 2 points to draw a line. A line has 2 points. So that means I would end 1 point short in terms of the number of lines. This will give me the right number of line segments. Okay, but how do I know how many line segments that I have? Maybe it has something to do with list again, right? If you go through list, it tells you the length of list, right? Seems like that would be useful, but that by itself is not all that we need. Okay, we need actually something else, because we don't want the length of the entire list, because that would give me the total number of points. I want the total number of points minus 1. Because that would give me the number of segments of line. Is that okay? So we need to do a subtraction, and this is the part of App Inventor that really gets tedious. Just to do a subtraction, I have to do 1 click, 2 clicks, and then specify what I'm subtracting, and I'm only subtracting a constant of 1 here. So just to get to this point, I have how many clicks? 4 clicks, 5 clicks already. Okay, so that's really cumbersome. I'd really much rather just type it up. Okay, not quite done yet, because I'm not even specifying which list that we're trying to get the length out of. It is going to be points, because that's my local variable that is now a list. So we go to list, we go to variables, go to get, specify my local variable points. Phew, finally we're done. Okay. Are we doing okay so far with this loop here? We're starting with the number 1. I will start with the number 1. Then we go to 2 because the step is 1, 3, 4, and so on. It will stop after the last iteration. And in the last iteration, I has the value of the length of the list that we call points here minus 1 because we are just counting the number of line segments to draw in this case. Yep.
For step 1, we need to do a negative.
Say again?
For the for each list that part of it, what we need to instead of increment, what we want to decrement.
You can decrement if you specify a -1. Yeah. So you can have your start value to be larger than your end value. Then you specify step to be a negative value. It doesn't even have to be 1 or -1. It can be 2, -5. You can specify whatever you want.
I didn't know if you recognize the negative.
Yeah, it would. Yeah, I think it would. All right, so we got this part done. So the next thing is to specify what do we want to do inside this particular loop here. Since we want to draw something like a line segment, maybe it has to do with the canvas. And then we just go to draw line. Okay, that comes in very handy. One single block can do just about everything that we want. Now we have to specify what is the x and y of the first point and what is the x and y of the second point. At this point, it's really just a matter of tedious coding. Okay, so what do I mean by tedious coding? Okay, let's take a look here. Because what we're doing here is to get to the list. Okay, everything has to start with points. Then we have to get to the right pair within the points, and then we have to get to the right x and the right y of that particular point. So we're just really stacking up a lot of access into the list. Okay, we'll go to lists here, and then we'll say we are trying to pick something from a list. Okay, we are selecting an item from a list here. Okay, so I'm going to construct this step by step, and you guys can basically see eventually what are we actually accessing. Okay, all right. Okay, so I'm gonna copy and paste this 4 times, and after we are done with this using the tedious way, we'll try to see if there's a more elegant way to do this. Okay, but not before. Okay, so at the very last level, I want x1 to be the x coordinate of a pair. I want y1 to be the y coordinate of a pair, and then x2 is the first again, and then y2 is the second again. So when you just want to work out the index, that's the easy part to work out, okay? Because we just have this one being 1, and I'm gonna do the lazy thing. This one's gonna be 2 because the y coordinate is the second item in a pair that is representing a point. And then we'll drag and drop this one over here. Okay, that's done. Okay, but what is this list? Well, this is not directly from points because points is a list of sublists. I'm trying to get to the first and the second of a sublist. Okay, so we have to get to the sublist first. Whatever I plug in to the socket over here has to be a sublist that only has 2 items. Is that making any sense?
Yeah. Select list.
So once again we have select list item. So we'll go to list, and then we get to select list item. And this time the list is my local variable points. Okay, we're gonna drag and drop that here. Okay, and the index is now controlled by the loop. In other words, it's controlled by I. Okay, so we will go to variables, get I in this case, and it will be the same for the y coordinate for the first point. So once again we have points, I, like that. But in the second point, it will be the next point, right? So I cannot just use I have to use I plus 1, okay? So I can still drag and drop, some of this stuff here. So I'll just go ahead and copy and paste. And if we copy and paste, oh, no, this one I don't want to copy and paste because this has to change. Okay, so we're gonna have to go to math again, specify the add operation. Okay. It gives you the ability to add more than just 2 items. That's why there's a little plus here. So we want to add I, which is the index controlling which element we are looking at in the global list, or the local variable points. And then we just want to add one. So we go to math again, specify a constant of 1. And that's it. Okay, this is all coming from points. And now we can go ahead and copy and paste this to over here, and then re-specify the local variable points and also the local variable I. And I think this is it. Are there any questions about this code?
Yeah, what's the 1 and 2 on the first select list item? I don't
Okay.
understand what that is.
All right. So what you want to do is to kind of visualize, what the list looks like in this case. Dry marker. Over here. Okay. Okay. So your list looks like this. Okay. This is a very conventional way to write a list, is to use parentheses to indicate the start of a list, and then use the matching close parentheses to match the end of a list. Okay. So my list may be like this. Okay. So 32, 64 is the first point. Okay. This is the x coordinate of the first point. This is the y coordinate of the first point. The second point may be at 36 and 61. And then my third point may be at 40 and 57. Okay, so let's just say that I only have 3 points in my capture. Okay, so now we have a list of 3 items, and then each item by itself is also a list. When we want to draw the lines, we want to specify 34, 64 as the first point of the line, 36, 62, 61 as the second point of the line, right? So that means I'm referring to the first item of the first item of the list. But when I get to the y, it's the second item of the first item of the overall list. So that's basically what that portion is trying to specify.
Okay, thanks.
Sure. All right. So I think we're done with this particular experiment. Yep, go ahead.
Row the list.
I only draw it as a row, but you can combine all the rows into one single long line. It will still be a list of lists in this case. This came from the good old days of Lisp, which is also an ancient programming language, but it uses parentheses to indicate the beginning and the end of a list. So you can imagine, when you have really complex data structures, you have a lot of parentheses flying in every direction. And they have special editors that can match a begin open parenthesis with its matching end, wherever it is. Yeah, Vim does that. Yep. But in some editors, it will even open up. It will split the window into 2 if the end parentheses is not on the same screen, because Lisp programs tend to be like that, really long with an open parenthesis that will match something that's way down there. All right, so I'm kind of excited. Let's go ahead and once again, download this code to this particular computer, re-upload it, and then we'll test the program again. Okay. I know this step is kind of cumbersome, but once you have everything set up, it's really just running the same command again on the command line. Some of you can probably write a little batch file and make it more automated. There are ways in Linux to monitor the quote-unquote freshness of a file. So when a file is changed, it's modified, it can make it trigger an operation. So in this case, if I monitor the the file called dragrecorder2.apk, I can actually link it to the action of running adb install-r, that file name again, all by itself. So every time I download the file, it automatically re-uploads it to the emulator. And I think you can do that in Windows too. It's just that I'm not familiar with the system call in Windows to do that. It's getting there. Okay. So I'll go ahead and switch to the text window, and get ready for this action. Yep.
How accurate is this drag? Like, how much is happening points? Like, is it full every half millisecond or half a second, or like?
You can actually capture the time too. I can show you kind of how to do that too. Okay, so let's go back to the browser. It's still okay. There we go. Okay, we want to save it to the same name. So as I said, I can probably write a script that can monitor the status of this file. The moment I overwrite this file, it will trigger the action to reinstall it on the emulator. But it's not too bad to have to just rerun the same command over and over again. It's not too bad. Okay, it's being done. Switch back to the emulator. You can see it's highlighted in red because it's being reinstalled. Alright, this is all done. Go ahead and run it again. Alright, so the first screen doesn't really have a lot of change. I'm still dragging this little ball around like this. Okay, and it will still display the coordinate like this one. Except this time, if I click the button to draw in another screen, it will switch to the second screen and actually draw the lines. Okay, now obviously this app doesn't serve any purpose, right? Why don't I just draw these lines in the first screen to begin with? The whole point is really just to illustrate that I can pass an entire list from one screen to the next. Okay, because if I can pass a list of sublists of numbers, I can just as easily pass a list of pairs. Now, if I can pass a list of pairs, that means I can pass configuration data. I can pass anything I want to the other screen. Okay, so this has a lot of implications as far as what kind of app we can write. So we only have we are running out of time. Okay, but I can leave this to you guys. Okay, modify this program just a little bit here. Okay, add 2 more buttons. Add one button to say save drag points. Add another button to say restore drag points. Okay. Now once you do that, you need to use TinyDB for that purpose because that's the persistent storage. So once you do that, what you can do is to test the program, right? Okay. Do exactly the same thing here, except you press the key, the button that is labeled save drag points. Close the app completely. Turn off your device. Restart it. Okay, get back to the same app, and then click reload or open drag points, and then switch to the second screen and see if you can draw that. Yep.
Does the emulator have persistence?
Not across cycling power, but you can at least close the app and then restart the app. Shutting down the app is really just yeah. But the app. If persistent storage is working, it should work, after you shut down the app just by the back button. And then when you restart the app, it should start from scratch if something is not saved permanently. Okay. So are there any questions?
So we use first to from scratch? Or you?
Oh, okay. I see your point. I see your point. Okay, I'm going to upload this one, so you can actually see it in the gallery. Okay, so I want to make this visible to everybody. I wrote really simple stuff, and people actually download my programs. I'm just puzzled. It's like, but this is not an actually useful program. It's only here to illustrate a single little thing. Yep.
That drive app that you told me to upload.
Uh-huh.
You got to download it like 20 times.
I wonder whether it's bots actually doing it. Can it be people, or is it just really bots doing it? Okay, so I'm gonna dismiss this screen, go back to my designer, make sure everything is saved. All right, so now we get back to, let's see, gallery. Okay, wait, okay, one more thing. Before I upload anything to gallery, I have to download the source code first. So I'm gonna click this thing, click download source, and save it to my local hard drive. Okay, so this is all done. And then we go to gallery. And the gallery is not even linked to my account yet. Okay, so the first thing I have to do is to log in to submit apps and comments. So for those of you who's a little bit concerned about, well, can other people see everything that I'm working on? The answer is no. Okay, the people who run this website, yes, they have access to everything that you save on the remote side. But as far as the other users are concerned, until you upload it to the gallery, it is not visible. Okay, so I actually have to log in again to the gallery because it's not even linked to the other portion. Now that I have logged in, I can upload. I can go to My Apps here. I already have an update list of pairs as a program that I have uploaded, and this one already has 12 downloads. I mean, that's just puzzling because this program doesn't do anything except to illustrate how to work with a list of pairs, which is a computer sciencey kind of thing. It's not fun, it's not entertainment, it's not a game, it's really to illustrate how to get one thing done. And I still get 12 downloads and 32 views. So now I'm going to add the other one. So I'm going to add drag recorder 2. Okay, another sample program for cisp362 students at ARC to play with. Because cisp362 is also currently being offered at Folsom Lake, where they copied and pasted my entire curriculum.
Oh.
Yes, I can record that part too because it is entirely true. It's not libel.
You can't copyright it?
No, because the entire district shares a database of curricula. So, any college can copy and paste it from any other college. Now, if I want to start a class, I might refer to the description, but I would do everything else, on my own, just because I don't usually like the way other people do things. I just want to do it the way I want it. Okay, this is for education. Select source file. It's going to be drag recorder 2.aia. Okay, so the file has a different extension. I also have to select an image, which is really troublesome. I mean, why do they have to do this? Okay, fine, I'll do that.
Because they're not expecting you to upload samples.
Yeah, you have to specify it, like a image. So I'm gonna drag and drop this. Save. Sorry, go ahead.
They're just expecting you to upload real stuff instead of samples.
Okay, now I have a little bitmap corresponding to this app here. Specify the image. Drag recorder. Where did I put it? Right here. Oh. Did not put it in the right place.
You have an AIA?
No, but I saved in PNG already.
Oh, PNG.
Yep, go ahead and do it again. Take a snapshot. And save. Oh, it's saved it to my user folder, that's why. Okay, so I can just go to that folder and find it. Okay, back recorder 2. Here we go. Alright, so now we have the file, we have the image, we have education, and I can also add any type of tags that I want. It really helps people to speed up their search. Okay, so we can say list, drag, canvas. Okay, and I think that's all I need to specify
sample.
here. Oh, sample. Very good. Boring. Save application. I think it's saved. So if you go to the gallery, you should be able to find it now. Now, if you just want to browse around, you don't even have to sign in to the gallery. It's just like YouTube, okay? You just go there without signing in, and you can just look at stuff, okay? If you want to download, I think you do have to sign in if you want to download.
Did it save?
I don't know. Let's see. Let's go to My Apps.
I think it's in the screen until it properly exits.
Save application.
Huh. Oh, I guess that's just the extended options for that.
Okay. So we can can switch back to home, go back to my apps. Oh, I see. So I can.
So you can just hit that little arrow in the top left corner.
Top left.
You scroll down, but scroll back up. There you go.
Okay, yeah, so this is one, and then that's the other one. Yep, there we go. So you can go to home, and you can basically browse and just find out what other people have been doing with App Inventor. And now it's uploaded. Call me. Food places. Well, it's kind of cool. And they even have Gangnam Style. Well, I know what I'm gonna do next. I don't know about you. All right. So, are there any questions? I mean, not only am I teaching you, the use of lists. Now we also know about the gallery, and you can just download my project from the gallery and work with it. I just want you to add, save and restore. Okay, use TinyDB for that purpose, just so that you have the confirmation that you can save and restore entire lists from TinyDB, which I think is going to be a really cool and handy feature, because now all your configuration, everything that you want to save, if you put it into a list of pairs, you can pass it along to the next list. The next screen. You can change it, pass it back to the first screen. You can save it, you can restore it. You can do all kinds of cool stuff, and it only uses up one single global variable. That really is the cool part. All right, so that will end today's lecture. You still have your active homework assignment with the drive and steer. So that part is still something that you have to work on if you are not done with that yet.